Okay. Okay. The number of cells in the Carnot map, the total number of possible input variables combination. Okay, right? Okay, so like you have mentioned earlier, you don't have class at 11, right? So I hope no clash with other lecturer lah. So then we can continue, do it slowly, yeah. Okay. Okay, the number of cells determined by using the formula 2 power of n. Okay, where n is the number of input or number of variables. So the variables that you have is 2, right? So 2 power of n or 2 power of 2 is equivalent to 4 cells. Okay, what if okay, what if you have, okay, let me type this one slow. Okay, lagging. Okay. Okay, what if you have, okay, taking some time, 3 variables. Oops. Okay, let's say you have n equivalent to p plus q plus q plus r. Okay. Okay. So and let's say you have n equivalent to p q p plus q plus r. Okay, or p or q or r. This is not plus, this is n or. Okay. So in your opinion, how many boxes should we have? How many boxes?
8.
8 boxes. Okay, 2 power of 3 equivalent to 8. Then we can have a look to the following example of Carnot map. Okay, before that, okay, the process of simplification of using Carnot map we call as minimization. Okay, or simplification lah, minimization, resulting an expression which contain fewest possible terms. Okay, right. Okay, so as you can see here, okay, when you see the intersection of 1, okay, so this is what we call as the term. Okay, so if you have more than 1 ones, okay, therefore you may have sum of products. Okay, so later on we will have sum of product. For this case, you can only have one term. Okay, therefore there will be no sum of product lah. Okay, let's say you have another one here, so you have a sum of product. So the first term plus with the second term or second product. Okay, right. Okay, so the Carnot map, okay, the reason of learning Carnot map is to perform the minimization or just like simplification of Boolean expression. Okay, so we will simplify the expression, okay, becoming the fewest possible terms and fewest possible variables. Okay, after mapping the SOP expression, sum of product expression into Carnot map, the next step is to produce the simplified SOP expression in groupings of 1. Okay, so what you can see here, okay, we only concern with the output equivalent to 1. Am I right, class? Is it clear?
Yes.
Okay, so this one we call as groupings of 1. Okay, so this one we call as to find the groupings of 1. So we only concern the term or the expression for the groupings of 1 when you see the expression is equivalent to 1. Okay, right. Okay, the rules of Carnot map. Okay, the group of Carnot map can be either 1, 2, 4, 8 or 16. Okay, so you may have 2 or you may have 4. Okay, or you may have 8 or you may have 16, but you cannot have 6 boxes. Okay, so the group can only contain either 1, 2, 4, 8 or 6, which is equivalent to 2 power of n. Okay, each cell in the group must be adjacent to 1 or more cells in the group. So this one we call as adjacent. Okay, adjacent. Okay, must group the largest possible number of ones. Okay, so this is only one example, which is the simplest form. Okay, you cannot see the largest number of ones, but later on you will see an example which you have more ones. Okay, let's say you have one here, one here, one here, and one here. So all together we call as the groupings of 1. Okay, make sure each one of the map must included in the at least one group. Okay, the ones has already in a group can be included in another group as long as it is overlapping groupings including non-common number of ones. Okay, so don't worry about the lengthy statement. So we'll see from example here. Okay, right. Okay, have a look to the Carnot map to the left. Okay, have a look to the Carnot map to the left. Okay, right. Okay, the Carnot map to the left. Okay, how many variables that we have, class? How many variables?
3.
3. Okay, so in your opinion, how many boxes or output should we have?
8.
8. Right, so that's why you have 8 boxes. Sorry, 8 boxes here. 1, 2, 3, 4, 5, 6, 7, 8. Are you clear so far, class?
Yes.
Are you clear? Okay. Okay. Let's try to derive the the Boolean expression. Okay. So for this case, we have so many terms. Okay. We have so many terms, and then we need to produce the sum of product. Okay. Later on, we need to produce the sum of product. Let me check whether we can hide this one. Okay. Right. So okay, kita sorot dulu this one. Okay, right. Okay. Okay, my system is lagging. Okay. Okay, we refer. Okay, tak apa, saya tutup sikit. Okay. Okay, we refer to the Carnot map to the left. Okay, I have closed the answer. So let's derive the product here. Okay, let's derive the product here. Okay, before that, okay, I want each of you to have a empty sheet. Okay, I want you to have an empty sheet and draw the Carnot map. Okay, draw the Carnot map so that we can do it step by step. Okay, draw the boxes. Okay, right. Okay, so how many boxes we should have for 3 variables, class? Once again, how many boxes? 8. Okay, so this one I move to the left. Okay, so we have some space. Okay, right. Okay, so if you have 3 variables, you may combine any 2 variables. So let's say AB, okay, and the top one. I minimize the size. Okay, and the top one we have a C. Okay, right. Okay, so we refer to the C first. Okay, if C only one variables, okay, only one variables. Okay, so how many input combination for only one variables? 2, right? Either 0 or 1. Are you clear, class? Is it clear?
Yes.
Okay, do it with me. Yeah, we do it together. Okay. Okay, and then we have and then because we have 3 variables, okay, therefore the other one we have to combine A and B. So it is as if A, B, and A and B and C actually. But in order to draw the Carnot map, we have to separate because we cannot put it together as A and B and C. So we put it as A and B and then end with C. Okay, are you clear, class? Is it clear? Clear, class?
Yes.
Okay, now we try to to resolve the input combination for A and B. So A and B. So A and B, what is the first input combination? A0 and B0. Am I right, class? Is it true?
Yes.
Yes.
0 and 0. So this one, whenever I type A0 means that this 0 is belongs to A. Are you clear? Are you clear, class?
Yes.
Okay, and another B is another 0 is equivalent to B. Is it clear, class?
Yes.
All right, good. Okay, now we have oh, sorry. Okay, we have A equivalent to 0, B equivalent to 0. What is the following input combination, class? After 0, 0.
0, 1.
A 0 and
0, 1.
B 1. Am I right? Betul ke?
Yes.
Okay, right. Okay, but in order to do Carnot map, Okay, normally your input combination will be 0, 0, and then 0, 1, and then normally 1, 0. Am I right? Is it true, class?
Yes.
Yes.
Okay, but in order to derive the Carnot map, so this is being done by or being researched by Carnot already lah. Okay, so we no need to question his decision lah. Okay, right? Okay, in order to derive the Carnot map, instead of following with 1, 0, you continue with 1, 1. Okay, okay. Are you clear, class? Is it clear?
Yes.
Okay, so you have to continue with 1, 1. Okay, what about the last one? What is the remaining one haven't input combination haven't inserted?
1, 0.
Okay, one is for
1,
what? A or
0.
B? The value for one equivalent to what? A or B?
A.
A.
What
A.
about 0?
B.
B.
B. Right, get it,
B.
class? Are you clear? Okay, now, okay, we want to derive the first expression first. Okay, we want to derive the first expression. Okay, so the first expression, the value of 1 is here. Am I right, class? Is it true? Is it true, class? The value of 1 is here. Betul ke?
Yes.
Okay, so let's derive.
Yes.
Okay, let's derive. Make it center. Okay. Okay, please bear with me. Okay, let's derive the expression. Okay, based on the first term. Okay, okay, okay. What is the expression for this one? This is equivalent to what? For this one, the one with green color. What is the first expression? First term. The one in sorry. The one with green color lah. I make it as green color. Okay. Okay. What do you think the term for this coordinate? Okay. Anybody
A
want to
bar.
volunteer? Nama? Nama? The rest.
Shafika.
Okay, Shafika aja. Shafika. Okay. The rest. Okay. Cuba check with Shafika's answer. Whether your answer is correct or not. Shafika dah dapat bonus mark. Okay. The rest, please check your answer. If your answer is correct, means that you understood and you are able to score the midterm and you're able to score this subject. Okay, Shafika, what is the term for this intersection? What is the expression?
A bar, B bar, C
Bar.
bar.
And C bar. Okay, the rest. Are you agree with Shafika's answer?
Yes.
Yes. Why? Because A equivalent to 0, which is A bar, B equivalent to 0, which is B bar, and C equivalent to 0, which is C bar. So this is actually the product, A and B and C. So in order to derive the expression, it is equivalent to A bar and B bar and C bar. So it is also equivalent to, A bar, okay, and with B bar, okay, and with C bar. So it is equivalent. Okay, everybody clear about this? Everybody clear?
Yes, sir.
Clear.
Yes.
Yeah. Okay. Now we go on to the much more complex expression. So then we have done this one lah. Okay. So I can unhide lah. Okay. Can unhide this one. Okay. So check Shafika's answer. Shafika tadi with the correct answer. Is it correct? So correct. So Shafika's answer is correct. Now we want to derive the following term. Okay. We want to derive the following product term. Okay, right. Okay. Just now you see only you only have one, right? For this case, can you see we have so many ones? Can you see here, class?
Yes.
Okay, so this is what we
Yes.
call as groupings of one. Okay, so this is the most effective rather than circling one. Okay, you have to find the biggest groupings of one. Okay, so the groupings of one, like you have seen earlier in the theory. I Okay, okay. The groupings of 1 must be in the form of 1, 2, 4, 8, or 16. Okay, okay. For this case, okay, what is the groupings of 1? Is it 1? Is it 2, 4, or 16? How many cells for the groupings of 1? This one. How many cells involved?
4.
2, right? 2. Can you see here 2? Can you see the separate groupings of 1? Nampak tak? Dia separate. This is only for 2. This is only for 2. This is not 4. This is a separate one. Can you see, class?
Yes.
Because we are we are resolving, okay, the product for the second term. This one. Okay, right? Okay. So this is what we call as groupings of 1. Okay. For this case, okay, right? If you refer to this, okay, the the one that I'm pointing now, okay. What is the expression for this? A and B, right? Am I right? A and B? Because A equivalent to 1 and B equivalent to 1. Class, can you see here? A and B?
Yes.
Okay. What about this one? This one is also A equivalent to 1 and B equivalent to 1. Right? Okay, therefore, we can circle this one. We can circle this one as, okay, okay. Okay, both A and B is equivalent to 1, right? Okay, right? Therefore, we can put it as A and B. Where's that? Mana color tadi? Okay, sorry. Here. Okay, then we have A and B expression. Okay, now I want you to derive the one to the vertical. Okay, the one to the vertical. Okay, this one I hide. Okay, then I want a volunteer to tell me what is the answer. Okay, don't view the answer. Okay, I want you to give your answer. Okay, okay, okay. Are you clear about the horizontal groups of 1? Everybody clear? Class? Cepat. Respond please.
Yes.
Okay, right. Sekarang I want you to derive the terms for the one vertical. The one vertical here. Because we want to derive the sum of product. Okay, so in 1 minute, I would like to have a volunteer to tell me what is the answer, okay, for the groupings of 1 here. What is the term here? Okay, so by 11:21, I want one volunteer to tell me what is the answer.
Yeah.
Okay, question? Anything you want to share?
The answer.
Yeah.
The
Nak
answer
jawab?
is yes.
Okay, dah. Nama?
Aida.
Aida, okay. Okay, the rest check with Aida's answer. So Aida, so what is the answer?
The answer is B and C.
B and C, correct. Why? Because for this coordinate, you can see, okay, C equivalent to 1. Okay, we have to find the similar output equivalent to 1. C equivalent, always equivalent to 1. Okay, and for this one is B is always equivalent to 1. So the terms that we get here, okay, it is equivalent to B and C. Okay, okay. Everybody clear? Everybody get the same answer, class? Quick.
Yes.
Yeah, okay. Now, my next question, I hide this one again. Okay. Dah lambat pula nak tutup jawapan ni. Okay. Okay, right. Okay, I want any of you to derive the sum of product expression based on the terms that you have derived earlier. Okay, anybody volunteer to derive the Boolean expression? Quick. Okay, volunteer. Don't refer to the answer. Okay, let me go through with you first. Okay, right. So after you have seen the scenario being given in the midterm exam, okay, you need to derive the truth table. After you have derived the truth table, you need to derive the Carnot map. Okay, after you have derived the Carnot map, you have to find the term. Okay, you have to find the term and you have to find the product. Okay, and finally, actually it's not finally lah, there are some other steps. Okay, you need to derive the sum of products ataupun boolean expression. Okay, right, after you have derived the sum of product expression, you need to derive the circuit diagram, which is the logic gates, right? Okay, before that, let's derive together the boolean expression for this kind of map. Okay, so the boolean expression, you need to perform the sum of product for the following term. Okay, right? Okay, so the first term is A and B, right? Okay, what is sum of product? You have to sum all the product. Am I right, class? Is it correct?
Yes.
Okay, so A and B plus with what?
BC.
BC, correct. Nama siapa? Nak bagi bonus mark. Nama?
Hasana.
Nama?
Hasana.
Hasana. Hasana, teruskan eh. Okay, well done Hasana. Okay, AB plus with BC. Okay, then plus with what?
A bar.
A
B
bar.
bar.
Okay, and B bar and C bar. Okay, so finally you plus with the last term, which is A bar, B bar, and C bar. Okay, then you will get the full mark for the Boolean expression. Okay, are you clear, class? How you can derive the Boolean expression from the
Clear.
Carnot map? Clear?
Yes.
Yes.
Okay, then we have a look to the following example. Okay, following example here. Okay, so as you can see here, okay, this is the other way to derive the Boolean expression. Okay, right? Okay, so firstly, you derive the vertical one, which is the easier one. Okay, you refer to this vertical one, you find out, okay, for the output equivalent to 1, which input is equivalent. Okay, for this case, which one is equivalent? A equivalent to 0, similar, right? Am I right, class? For this vertical one, okay, this is always A equivalent to 0, right? Am I right, class? Quick, class, the first oval shape here.
Yes.
Yes, right?
Yes.
Okay, instead of A equivalent to 0, because B is not similar, you can see here B equivalent to 0, and this is B equivalent to 1. So you cannot take either B or B bar, right? So you can only take A bar, because A equivalent to 0 is equivalent to A bar. Are you clear, class? Everybody clear? Question? Or clear? Class, is it clear?
I don't actually. Can you explain it again?
Okay, so you can see here, in order to derive this first groupings of 1, can you see the groupings of 1 that I'm pointing now, class? Can you see?
Yes.
Okay,
Yes.
the one vertical, right? Okay, same like previous example, you have to analyze, okay, which input which is similar that produce output equivalent to 1. Okay, the first one we refer to A lah. Okay, right? Is it A similar for the vertical one? Similar, right? Am I right?
Yes.
A,
Yes.
it's
Right.
always A equivalent to 0. This one also A equivalent to 0. Am I right, class? Betul ke?
Yes. Yes.
Right? Okay, then B is not similar, because B can be either value of 0 and 1. Therefore, you cannot pick B. You must only take which is the variables, the input value, which is the same, which is the A, and the value of A is 0, right? So should we take A or A bar?
A bar.
A bar. That's why we have A bar here, right? Okay. Okay. B. Can we take B? No, right? Because the value of B is not similar. Input value of B is not similar. Okay. Any other variables that we can pick instead of A, class? C we can take, right? Because for this coordinate, okay, both C is equivalent to 0. Am I right, class?
Yes. Yes.
Okay, So should we take C or C bar?
C bar.
C bar, because the value of C is always 0. So that's why we have the product A bar and C bar. Okay. Okay. Okay, let's derive together the one vertical. Okay, the groupings of one vertical at the bottom here. Okay, then in half a minutes, okay, we will discuss the answer. Right, refer to this one. Okay, right. Okay, which variables, which is the input value, is similar? A or B? This one. For this vertical one. Okay, volunteer please.
A.
A, right? Okay, because A
Yes.
is always 1. This one is A1, this one is also A1. So you can put A. Okay, you can put A. Jangan keluar B pula. Okay, right. Okay, what else? Instead of A, what is other variables that you can include?
C.
C. Why C? Because C is always equivalent to 1, right? You refer to this
Yes.
coordinate, right? Okay. Okay, the rest. Are you agree? Siapa yang jawab tu? Boleh semua? Siapa jawab? Nama?
Hasanah.
Okay, Hasanah. Okay. Okay, everybody agree with Hasanah. The answer is C. Jangan tengok jawapan. Tutup mata. Is it correct, C? C, right.
Yes.
So this is A and C, right? Okay. So you have A and C. So we can have A, C plus with A bar and C bar, right? Okay, so this is what we call as wrap around agency. Okay, wrap around agency. Okay, means that you can see this one is just like a mirror reflection. So the good news is, okay, can you see the semi-oval here, class? Can you see the semi-oval? Separuh bulatan in Malay. Can you see?
Yes.
We have two semi-oval, right? Okay, half of circle. Okay, top and bottom. So when you see something like a mirror image, okay, this is what we call as wrap around agency. Can you see the arrow here? Means that you can further simplify this expression. Okay, right. Okay, so let's investigate this expression here. So maybe I put a fresh sheet. Okay. Okay, in your opinion, okay, what is the expression for the top one? What is the suitable expression for the top one? The top semi-oval. Okay, what is the term that's suitable? This one. Which variable is input value is the same, class? Quick. Okay, let me take this one. Oops. Okay, I cut into half. Okay, put it here. Okay, cut another half. This one. Right. Okay, class. For this one, okay, we refer to the one I have pointed now. Okay, okay. So what do you think the term, the product that you should get here? What are the input value which is similar? Quick, class.
A bar, B bar.
Excellent. Nama? Nama?
Nasim.
Again?
Nasim, Nasim.
Nasim. Okay, very good, Nasim. Okay, so Nasim A bar and B bar. Okay, the rest agree with Nasim's answer. Setuju tak?
Yes. Yes.
Okay, right. Anybody volunteer? Nasim nak jawab ke yang semi oval yang bawah ni, Nasim? Ke belum ada jawapan lagi?
Boleh je.
Boleh. Okay. What is the answer for the bottom one?
A,
A,
B bar.
B bar. Excellent. Oh, okay. Okay. So the bottom one. Okay. The bottom one is A and B bar. Okay. Okay. Therefore, okay, if you see the mirror image like this, okay, if you you see the mirror image like this. This one we call the simplification technique we call as wrap around agency. Means that for this one we can further simplify. Okay, okay. In order to further simplify, you can find the input which is similar. Okay, which one is similar? A or B similar? Class.
B.
B. Therefore, you can further simplify. You can just take. Okay, okay. You take B or B bar, class.
B
B ke
bar.
B bar? B bar. Okay, so you can highlight this one. Okay, so this one kita namakan sebagai wrap around agency. You can further simplify. Okay, therefore, okay, you can derive, okay, okay, menghasilkan only B bar. Right? Okay. Okay, everybody clear?
Yes.
Okay, so if you you see the mirror image like this, you can further simplify. So this is the idea of learning a Carnot map. Okay, you want to simplify the expression to the simplest form. Okay, therefore, okay, after you have identified the terms, okay, we no longer use this one anymore. Okay, no need A bar, B bar, and A and B bar anymore. So you can further simplify into B bar straight away. Okay, therefore, our final Boolean expression for this Carnot map is what, class? A, C, plus with what?
B bar.
Plus with B bar yang you buat tadi, plus with A bar and C bar. Okay, everybody clear?
Yes.
Clear,
Sir,
eh?
sir,
Yes,
can we
yes.
change the arrangement?
For which one? Which
Yeah,
arrangement you mean?
like if I answer AC plus A bar C bar,
AC plus with?
A bar C bar.
Can, no problem. You just
Okay.
rearrange these terms, right?
Yeah.
So you will get the same same answer. No worry. You can
Oh,
either jumble up pun tak ada masalah as long as you get the same sum of product. Am I right?
alright, alright.
Okay. So everybody clear? Okay. If you put A bar and C bar at the front pun no problem. Okay, like this lah. I straight away give you an example. Okay. Let's say you start with AC. Sorry, you start with B plus with dia lari ya. Okay. So sekejap delete. Okay lah, tak apalah. I think because it is take a lot of time to rearrange the bar. Okay, so you get what your friend was asking, right? So you can either put A bar and C bar at the front, okay, or you can put B bar at the front. No worry. Okay, as long as you have the same sum of product. Okay, I hope everybody clear. So we move on to the following part. Okay, any question? Ada soalan ke?
Sir,
Yes.
nak tanya,
Okay, boleh tanya.
kenapa dekat top left box tu nilai dia 1?
Top left ni, this one.
Yes.
Okay. The value of 1 is being given by the earlier step, which is the truth table. Dapat tak? Jadi maksudnya dia the question in the exam macam saya beritahu tadi lah. Okay. They will start with a scenario. Okay. Dia bagi scenario, dia bagi a lot of story kan. Okay, then they will ask you to develop the truth table. Okay, after the truth table, you will get the input and the output, right? Okay, and then based on the input and output, you will derive the Carnot map. Siapa yang tanya tu? Who is asking me just now?
Aida.
Aida. Okay. Is it clear, Aida? Okay.
Yes.
So you get one. This one, the value of 1 is based on the truth table. Are you clear?
Yes, yes.
Okay. So you can get either okay. The question could be asked in the form of scenario, or the question could give you a truth table, or the question could straight away give you the Carnot map. Is it clear, Clark? Aida and the rest. Faham eh?
Sir.
Okay, right. Okay, so I think I can go on with the lab as well. So kita tengok yang Carnot map. Okay, which is for lab it is more comprehensive lah. Okay. So are you able manage to download the notes that I have uploaded yesterday, class? Can you download the notes, class? Boleh tak? Boleh download?
Boleh, boleh.
Boleh eh? Okay, so you can refer to the notes lah. So I have uploaded the latest notes. Okay, so this is the Carnot map that you have learned recently, right? Okay, so for this case, okay, A equivalent to 0, B equivalent to 0. So you can the mean term you can call as A bar and B bar. Okay, so this one A equivalent to let me get the highlighter. Okay, A equivalent to 0, B equivalent to 1. So it is equivalent to A bar and B. Okay, so it is a long way step. You already understood, right? To develop the truth table, no point we go to the lengthy expression description. Okay, right? Okay, so this is the example of the truth table that the one like Aida was asking just now. Okay, Aida yang tanya tadi kan, right? You can have A and B and C. Okay, for this case, let's derive together the results for the input. Okay, right. By referring to the first input A0, B0, and C0. Okay, we less concerned about this one. We concerned with the output which is equivalent to 1. Okay. Okay, this one I think we cover later lah because they didn't state the output. Okay, right. Okay, this is what Aida was asking just now. Okay, how do we get 1 here? Okay, how do we get 1 here? Okay, so we get 1 here based on the output from the truth table. Okay, so we can empty the boxes first in order to go through again with you. Okay, we empty this box. Okay, empty this box. Okay, we empty this box. Okay, then let's try to do it step by step together. Sorry. It's not empty. Okay, class. Okay. Okay, let's have a look to the first box. Okay, can you see the box that I'm highlighting right now, class?
Yes.
Okay, right. Can you see the truth table at the
Yes.
top? Okay, so this is how the schema for the midterm being configured lah. Okay, right. So you concern with the output is equivalent to 1. Okay, which is this part lah. Okay, right. Okay, so you concern with A0 and B1. So when you do A or B, okay, A0, B1, A or B, so the answer will be 1, right? Okay, so let's figure out where should we put 1 in the Carnot map boxes. Top left, top right, bottom left, bottom right. Okay, for this one, okay, A equivalent to 0, B equivalent to 1. Okay, A plus B equivalent to 1. Which box, class? Which box? Top left, top right, or where?
Top right.
Top right. Okay, one of your friends saying it is a top right. Okay, A equivalent to 0. Okay, and B equivalent to 1. Is it this one, top right? Betul ke?
Bottom left, bottom right, bottom left.
Bottom left.
Bottom left. Okay, are you sure? Are you sure?
Yes.
The answer?
Yes.
Okay, so
Yes.
let's check the answer. So you get here, okay, for this output, okay, right? A equivalent to 0, A bar, okay, then you all with B, which is B, So the output will be 1. Okay, can you fill up the rest? Okay. Okay, so what about this one? This one is A or A bar?
A.
A. Okay, so A plus B. Okay, A plus B bar. Okay, so sorry, A and B bar. Where is A and B bar? This one, right? Okay, the output is 0 or 1? 1, right? Okay, so the output will be 1. Okay, so this is how to derive the Carnot map based on the truth table. Okay, so whenever the A is 0 and B is 0, A0 and B0, where is it? A0, B0, top right? A0, B0, the output will be what? A bar, B bar, A0, B0, so the output will be 0. Okay, and this is how you fill up the Carnot map. Okay, and then you will get the answer lah. Okay, are you clear, class? Everybody clear? Everybody clear, class?
Clear, sir.
Okay, so let's derive the the final Boolean expression. What is the final Boolean expression for this Carnot map? What is the okay? Therefore, okay, in order to derive the Boolean expression, you have to do the groupings of 1. You still remember just now we learned about groupings of 1?
Yes.
Okay,
Yes.
so okay, so which one the groupings of 1 that you can do first? This one and this one, right? Am I right?
Yes, correct.
Okay, so therefore you can do the groupings of 1 for this one and this one. So this one is equivalent to what? Okay, which variables is similar? B, right? Okay, so this one, okay. Okay, for this one, okay, okay. What is the term for the groupings of 1 that I have highlighted now? What is the term? What input value which is similar?
B.
B, right? Therefore you put B. Okay. Okay. What about the rest? Digest first before we go on to the next groupings of 1. Okay. So this one is equivalent to B. Okay. Okay, the rest can digest first. Okay. Is it through B, class? Or we should include with other variables or just B? Class?
Just B.
Just B, eh? Okay, right. Okay. Okay. Okay, let's derive the next term. What is the next term? Okay, the following term. I unhighlight first this one so that easier for you to see. Okay. Okay. Which what about the following groupings of 1? This one, right? Alah, tak boleh. This one and this one. Okay. The one to the vertical. Okay. Right. Okay. Volunteer, please. Maybe from gentlemen. Okay. What is the terms for this one? These groupings of 1. What is that? A or A bar?
A.
A. Right. So the groupings of 1 is A. Okay. So we have A, B. Okay. So let's finish up so that you can get a full mark. So what is the final sum of product for this one?
A or B.
A or B, good. Or A plus B. Where is plus? A or B, excellent. Okay. Okay. So your final expression is A or B. Can you see? You can either derive the expression from the truth table, or you can derive the expression from the Carnot map. Okay. Any question? Or everybody clear? Class?
Yes.
Clear?
Clear, sir.
Okay, right. Okay, so we have a look to the other scenario. Okay, in case you will be asked whether the Carnot map is correct or wrong. Okay, so this is another scenario lah. Okay, right. Okay, you may as well refer to your notes. Okay, example of groupings of one. This is okay. Okay, don't see to the don't refer to the answer. Okay, the one to the top, yang the one that I highlighted now. Okay, hold on. Okay, is it true? The groupings of one, is it correct groupings of one, class? This one?
No.
No.
No. Why? Because it is not groupings of one. It is groupings of 0 and 1. So this one is incorrect. Okay, so supposedly which one?
The bottom.
Okay, the bottom. Okay. Anything else?
And the left side.
Okay, and the vertical, and the vertical. Okay, can have this one, right side. Okay, so you may have two groupings of one. This one and this one. Okay, everybody clear, class? This one. So they have shown you the answer. Okay, this one and this one. Okay, the top and bottom. Okay, so let's have a look to the other groupings of one. Okay, this one, is it correct? Macam kita buat teka silang kata in Malay. Okay, we just use a cross puzzle. Okay, is it true or false?
False.
False. You cannot do this way. Okay, so you can only do this way or and this way. Clear? Right. Okay, the following one, I think better make it smaller. Okay, this one, like a L shape, like a horse move. Okay, bishop move. Oh, sorry, horse move. Okay, is it correct groupings of one, class?
No.
No, so
No.
you have to do this way lah. Groupings of one. Okay, what about this one? Is it correct groupings of one?
No.
Okay, you may do groupings of one if there is only one cell applicable. But if you can have bigger groupings of one, okay, this is incorrect. So you have to do bigger groupings of one. Everybody clear? Clear? Class?
Clear.
Okay, and this is another scenario. This one we call as a wraparound agency. If we can see mirror images, okay, therefore you can have a simpler expression or simpler product term. Okay, or you can also have these types of a question. So you can have several groupings of one, this one and this one. Okay, this one and this one, and then you can simplify further. Okay, and then you can have just one grouping of one. Okay, and then you can have two cells groupings of one. Okay, so this is just a revision from what we have seen earlier. Okay. Okay, this is example of question, okay, which is popular lah, or reflection for midterm exam. So please bear with me. Let me resize or bring it. Okay, right. Okay, this is the type of question that could be asked in your midterm. Okay, can we start now, class? Can we start now, class?
Yes.
Okay, right. So like I mentioned to you earlier, okay, in your exam, okay, your exam will ask you, will be giving you question something like this scenario. Okay, then at the end of the your answer, you need to produce the circuit. You need to draw the circuit, right? So which is, let me show you the circuit. Okay, so this is the circuit. Okay, you get what I mean, class? Class, you clear my the rough idea that I'm trying to tell you?
Yes.
Okay, so you will be given, okay, in exam, okay, you just being given this scenario, okay, a circuit built with, based on the following, a circuit built with several gates, 3 switches, which is the input lah. Okay, the switches is the input, S1, S2, and S3, and 3 LEDs, which is the output, L1, L2, and L3. The circuit is defined as follows. Okay, L1 with light up if at least one switch is on. L2 with light up if at least two switches are on. And L3 will light up if all three switches are on. Okay, okay, you will be given just this question. Then you need to produce at the end, which is the circuit, because you are the future scientist to develop the computer, right? Okay, right? Okay, so the first step is you need to analyze this question. Okay, and then you need to develop the truth table first. Okay, so I give you about 2 minutes. Let's say you want to go for a toilet break or whatsoever, or for those that still online, or have no need to go to toilet, you can try to analyze this one. You can try to develop the truth table for this scenario. Okay, so afterward, I will give you about 2 minutes break. Okay, in order to digest or in order to figure out the following step. Okay, everybody clear? Is it clear, everybody?
Yes.
Okay, so we may take 2 minute breaks, or you can analyze the question, example of midterm question. Okay, right.
Sir? Sir?
Okay, class. Okay, class. Can we resume the class? Boleh ke?
Yes.
Okay, class. Okay, let's analyze this question. Okay, have you figured out the truth table, class?
Yes.
Okay, right. So you can, if I want to create another Excel sheet, it could be small in size lah, but I try. Okay, where's the Excel? Okay, this one. Okay, right. So you have to develop, or you have to create your truth table. This scenario. Okay, this is the popular question in exam. Popular question in exam. Okay, a circuit will be built with several gates and 3 switches. Okay, so you can create the input. Okay, so for the time being, how many input we have, class? How many input we have?
3,
3. Therefore, how many input combination should we have?
8,
8, right? So we have to have 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8, or 8 8 rows, right? Okay, so we have 3 and 8. Okay, so 1, 2, 3. Okay, so we have 8. Okay, so okay, how many output should we have?
3,
3. 3 output as well. Hold on. Okay, draw the truth table first. Okay, so we have input 3 and 8. 1, 2, 3, 2, 3, 4, 5, 6, 7, and 8. Okay. Boxes. Okay, and then we have 3 output. Okay, so and then okay. Okay, you may draw this one. This is the input. Input, and this is the output. Okay. Okay, draw the rest. Okay. Okay. So what are the outputs, class? We have S,
S1, S2, S3.
S1, S2, S3. Fill up the rest. S1, S2, and S3. Okay. What are the output that we have? L1,
L2,
L2, and L3, which is the light lah. Okay. Right. Okay. Maybe you will be given question that asks you to develop the vending machine, or to develop the anti burglary alarm system, right? So yes, a future scientist should be able to develop the circuit lah. Okay, right. Okay, so you can see here, okay, if you have 3 input, okay, therefore we have few input combination lah. So we have 0, 0, 0. Fill up the rest, okay. Okay, have you do it together with me, class? Okay, do
Yes.
it together, so that if you left this part, so you might if you do this part together, most probably easy for you to answer the midterm exam question. Okay, what is the following input combination? After
0, 1,
0, 0, 1. Okay,
1.
so as simple as that. You can see, yes, as you can see here, simple, right? Just by inserting all the input values, then you already have a marks. Okay, can you see, if you didn't know how to construct the truth table, how many marks could you miss? Okay, let's say 1 boxes consists of half marks. Okay, so let's say how many boxes we have here? Maybe 20 boxes. So you have lost about 10 marks. Are you clear, class? Is it clear?
Yes.
Okay, just fill up the rest. Okay. Okay, you have 1, 1, 0. Okay, sorry. Okay, and the rest lah. Okay, so far everybody clear? Everybody clear?
Yes.
Okay, right.
Yes, sir.
So you refer to the scenario. Okay, the circuit is defined by follows. Okay, L1 will light up. Okay, so dia kata L1. So I highlight L1. Okay, so I put different color, this color. Okay, they say that our L1 will light up if at least one switch is on. Okay, so let's say if only one switch is on. Okay, so means that any of the switch is on, so L1 will be on. So you have to fill up the rest of the truth table. Okay, right. Okay, what after this? Zero? Zero what? Quick, tell me.
0, 0, 1.
Okay,
0,
the
1,
top one
0.
is 0, 1, 1, right? Betul ke?
Yes. Yes,
Okay.
yes.
Okay, what about this one? Okay, the rest, cepat. 1,
1, 0,
1 0
1,
0.
0. Okay, this one.
1 0 1
1, 0, 1. What about this one?
1 1 1 0
1, 1, 0. Very good. Okay, the last one.
1,
1
1,
1 1
1, 1, 1. Okay, as simple as that. Okay, so you need to, if you know how to construct the truth table based on the scenario being given, you already get 10 marks. Okay. Okay, so you refer to the following statement. L1 will light up at least one switch is on. So you refer to the switch. Okay, switch on means that the value is equivalent to 1. Am I right, class? Am I right?
Yes.
Okay, so you find out where which switch is equivalent to 1. This one, okay, can have this one, okay, and then you can have this one, okay, right, and then you can have this one. Okay, you can highlight all the switch is equivalent to 1. This one as well. Okay, and the rest lah. Okay, right. So, so the scenario is L1 will light up, will on or 1 only if any of the switch is equivalent to 1. So where should we put 1? Should we put 1 here, class? Should we or shouldn't?
No.
Should not, right? Should not. Okay, so this one is 0. Okay, what about this one? Is it 1 or 0?
1.
1. Okay, what about this one? Because the input is 1, right? What about this one? 1 or 0?
1.
1. What about this one? 1 or 0?
1.
1 or 0?
1.
1. Okay, because they say that light will up if at least, if both is on, still we put it as 1. This one is 1. Okay, this one is 1. Okay, this one is 1. This one is 1. Okay, class, are you clear? Are you clear,
Yes.
class? Okay, now I give you about 1 minute to figure out okay the results for the following switch. Okay, L2 will light up it if at least 2 switches are on. Okay, so we refer to the next one. Okay, okay, L2 will light up if at least 2 switches are on. Okay, now we can clear this one. Okay, so L2 we use different color, maybe yellow. Okay, so okay. Now we refer to the L2 scenario. Okay, L2 will light up is at least 2 switches are on. Okay, right. Okay. This one is input 1. One is input 2, and so on. Right. Okay. So in order to to put 1 for L2, like L2 will light on, light up is at least 2 switches are on. Okay, which input should we put as 1, class? Which one?
0, 1, 1.
0, 1, 1, okay, or input 4, okay, or input 4, okay, okay, 0, 1, 1, we put it as 1. What else?
1, 1, 0.
1, 1, 1, 0, 1, 0, 1. Boleh tak? 1, 0, 1.
Boleh.
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 What else?
110.
110 lagi
111.
111. Okay. So now we dah dapat banyak markah kan? Okay, can you see? As simple as that. Am I right, class?
Yes.
Okay, now I want you to do the L3. L3 will light up if all the three switches are on. This one much more easier lah. Okay, so L3. Okay, so L2 just now I can highlight in yellow. This one. Okay, and then this one as well. Okay, and then this one and this one. Ada lagi tak yang belum highlight? Semua dah highlight Okay. Okay, for L3. L3 I use different color maybe. L3. Okay. For L3 will light up if all the three switches are Okay, L3 will light up if all the switches are on. Which input combination?
111.
The last one, right? So you put 1 here. Okay. So you put oops. Okay, so you put 1 here. Okay, right? Okay, so this one 111. Where is the color? Okay, class. Are you clear? Everybody clear?
Yes.
Yes.
Okay, simple as that. Then you already have 20 marks. This is the scenario for your midterm exam. Okay, right? Okay, and then you need to derive the equation or logic equation. Okay, L1 is quite easy as the truth table or except if all switches are zeros. In other words, okay, S1 or S2 or S3. Okay, okay. So the condition for L1, okay, okay. So we refer back to L1. Okay, refer back to L1. Okay, L1 will light up if at least one switch are on. Okay, so based on this truth table, okay, so we concern with this one, right? Am I right, class? Betul ke? Class?
Yes.
Okay,
Yes.
so you need to derive the Boolean expression for this one. Okay, so for L1, okay, you can say that, okay, if any of the input is 1, okay, so L1 will be 1. Therefore, the expression for L1 is equivalent to S1 plus S2 plus S3 or S1 or S2 or S3. Means that if any of the input is 1, L1 will be 1. Are you clear, class? Is it clear? Class, is it clear?
Yes, sir.
Okay, good. Okay, then we figure out the expression for L3. Okay, okay, L3 is the opposite for L1. Okay, because the condition for L3 I delete. L3 will light up if all the switch is on. Okay, means that in order to get 1, okay, all the switches must be 1, right? Am I right, class? For L3?
Yes. Yes.
Okay, so in order to get 1, so you need to use the AND gate. So if the S1 is equivalent to 1 and S2 equivalent to 1 and S3 equivalent to 1, so the L3 will be equivalent to 1. So the second equation for L3 is equivalent to S1 and S2 and S3. Are you clear, class? Are you clear?
Yes.
All right. Okay. Okay. And for L2 can be derived. Okay. L2 punya condition pula. Okay. L2 condition. This one we remove. Okay. Okay. L2 will light up at least 2 switches are on. Okay. If any of the 2 switches are on. Okay. Therefore, you can use this expression, Boolean expression. Okay. Okay. For this one is quite lengthy. So I want you to analyze later. I want you to digest later so that you can shorten our part and you can do your part, which is instead of you being spoon feeded everything by me. So I want you to analyze L2 by yourself. Okay, class, are you clear? Okay, class. Okay, so later on you can after you have done the logic equation or you have derived the Boolean expression. Okay, what do you think you need to do next, class? after you have derived the Boolean expression? You as the scientist, you need to develop what at the end?
The
Develop
logic.
from the letter C. Develop what?
Circuit.
Circuit, right? So that is the final your final destiny lah. Okay. The final thing that you need to do is you need to develop the circuit based on the logic gates. Therefore, you can draw the circuit in your midterm exam. Okay. So sekarang you can use the multimedia logic, right? Or you can use the multimedia logic. Okay. Right. So let me save supaya my system is not hang or crashing. Okay, whatever I didn't need, I think I better close before it hangs. Hold on, I hope it doesn't crash. Okay, after you have finished deriving the Boolean expression, you need to develop the circuit. Okay, before that, before you develop the circuit, okay, you need to simplify, okay, especially L2. Okay, right. So L2, after you have derived the equation for L2, okay, you need to simplify first. Okay, I'm sorry. I have overstep or overlook the following step. Okay. The next step, especially L2, you need to simplify the circuit, right? Okay, you remember, right? The steps, the simplification step that we have done earlier class. Can you still remember?
Yes.
This one, right? Okay, so after you have derived the lengthy expression, you try to simplify to the simplest form. Okay, try to simplify to the simplest form. Okay, like L2, we can have a lengthy expression. Okay, L2 is equivalent to bracket S1 and with S2 and with S3 bracket plus with bracket S1 and with S2 bar plus with S3 bar, right? Okay, for this one, this is the equivalent sum of product. Okay, and based on this one, you can expand and later on you can further improvise lah. Okay, so you have to simplify the expression. After you have simplified the expression, before you develop the circuit, okay, you may as well produce the Carnot map. Okay, and then after you have you have used the Carnot map, you can further simplify lah. Okay, so after you have derived the Carnot map, okay, then you can simplify, then you can prove that your simplification is similar to the simplification using the Boolean rules, Boolean's rules of simplification, right? Okay, so you can see here, whenever you do the simplification, you have the groupings of 1, 2, 2, and 2. Okay, so you can have 3 sum of products. Okay, in which if you can see here, your sum of products by using the Carnot map, the simplification equation is similar to the simplification that you have done using the rules of Boolean algebra. Okay, Boolean rules. Okay, right? Okay, after you have simplified, then you can develop the circuit. Okay, after you have simplified, you can develop the circuit. So this is the circuit lah. Okay, right? Okay, so you may refer to this circuit, right? Okay, let's say you have this equation. Okay, S2 and S3. So I hope my system doesn't crash lah. Input. So you can put the gates. So it's okay. So mine is crashing now. Okay. Because I'm losing some of the component. Okay. So anyhow, we come into conclusion straight away. Okay. Right. Okay. So based on the, let me minimize first. 7%. Okay. Okay. Based on the expression that you have derived. So I think this one should be better. 90. Okay, based on this expression that you have derived. Okay, so this one is S1 and S2. Okay, this one is S1 and S2. You can have S1 and S2, and then S1 and S3, Okay, sorry, this one is S1 and S3. Okay, so let me label this one. Right. Okay, so this one. Okay, for this logic gates, right? Okay, this one is what end with what class? This one, the top logic gates, the top end gates.
S1,
S1 and
S3,
S3. Okay. Okay. What about this one?
S1,
S1 and
S2,
S2. Okay, and S2. Good. Okay. Okay. What about the bottom one? S what and what?
S2,
S2 and
S2
S3.
and S3.
S3.
Okay. Right. Okay. So we have here. Refer back to the top. Okay, kena kecilkan lagi. 80%. Can we refer? Not sure. Okay. Okay. So we have here S1 and S3. Okay. And then okay, and then we have S2, S1 and S2. Okay, and then we have S2 and S3. Okay. Okay. What next? You need to OR everything, right? Okay. So this is L2 is equivalent to, okay, L2 is equivalent to what? S1 dot S3. Am I right? Is it correct?
Yes.
Plus with
Yes.
what? This
Plus with
this
S1 and S2.
okay, this one, and then S1 and S2. Okay,
S2.
plus with
S2 and
S2 and
S2
S3.
and S3. Okay, right. Yes, I hope everybody's still on the line. Okay, right. Okay, is it clear, class? Okay, so based on the scenario, so in the midterm exam, you will be given a scenario, or you will be given a lengthy question in the form of paragraph. Okay, the final output is you need to produce the logic gates or the circuit. Okay, so in order to produce the circuit, firstly you need to produce the truth table. After you have produced the truth table, you need to simplify the circuit. Okay, and then after you have simplified the circuit, you can simplify using the rules of Boolean algebra, or you can simplify using the Carnot map. Okay, and finally, based on the simplest expression that you have obtained, you have to develop the circuit diagram. Okay, sample of combination circuit. Okay, everybody clear? Class? Everybody clear?
Yes.
S.
Yes.
Yes.
Okay, so this is just a revision. For universal gate, we have a NAND gate. Okay, not AND means that we have an AND gate and then we have a NOT in front. Okay, so this is A and B. Okay, this is A and B, right? So you get, after you have a circle in front, this is a NOT. So this is equivalent to A and B bar. Okay, this is equivalent to A and B bar. And this is not. Can I edit? Okay. Okay, right. Okay, this one is A and B bar. A and B bar. Okay. Then, but this is not A bar and B bar. Okay. Okay, this is not A bar and B bar. It's not. It's not here straight away. Okay. Okay. The output is A and B bar. You have to perform A and B first, and then only you bar. Okay. So this is what we call it as A and B bar. Okay. And it is not A bar and B bar. Are you clear, class? Is it clear?
Yes.
Okay, right. Okay, right. And then this is a NOT gate. Okay, the equivalent NAND gates, you can also use the NAND gate. Okay, okay, this is just a revision. As I mentioned to you earlier, your midterm exam will cover only until Carnot map. Okay, so this is just additional reading. Okay, this is the AND gate. You can put this way, or you can also use this way, and you can still get the same result. Okay, or gates, you can also identify this way, which is more lengthy or which is more bulky circuit lah. Or no gates, you can also use this diagram. Okay. Okay, or I can just make it bigger in size. Okay, right. Okay, right. Smaller. The end for this part. Okay, in order for you to practice for your midterm exam, okay, you can answer this type of question. Okay, you can answer this type of question. Then you develop the truth table. After you have developed the truth table, you may simplify the circuits either using the rules of Boolean, or you can simplify using the Carnot map. Okay, but you need to know both because maybe in the exam asking you to simplify using both methods, either rules of Boolean algebra, or they ask you to simplify using the Carnot map. Okay, okay. Then finally, you need to derive, or you need to draw the circuit. Okay, you need to derive the circuit. Okay, so you can practice this question, and if I have created the submission link, you may submit to the learn link later lah. So you don't worry. Once I have finished creating the link, I will inform you lah. Okay, I'm sorry lately because I've informed to you my family in hospital. Okay, so maybe I will share in the short while. Okay, right. So this is just to finish up our syllabus. Okay, right, for this topic. Okay, we have done the Carnot map. Okay, and then the logic gates. Okay. Okay, so this is the logic gates for not and not or. If you can see here, instead of you do only, normally you have two input, right? A and B. For you can also use three input, A or B or C. So this is the symbol for or N class. This one. This symbol. N or O.
Oh.
Okay. So the exam could give you gates and ask you to state what gate is that. Okay, what about this one? N or O?
And
And okay. So for this case, the output, what is the output? Can I close the output? Tutup tangan jap. Okay, what do you think the output for this one? For the middle one?
X and
and
Y bar
Y
and
bar
Z.
and
Z.
Z. Okay, so this is the output, right? So you need to know how to derive the Boolean expression, or you need to know how to create the circuit based on the Boolean expression. Okay, right. So this is the popular question as well. Okay, you will be given. Let me view view page navigation, page display, enable scrolling. Okay, right. Okay. Okay, or you might be given the Boolean expression, then you need to draw the logic gates, or you need to draw the circuit, right? Okay, so you may also be given the other way around. They give you the circuit, they will ask you to derive the Boolean expression. Okay, are you clear, class? Is it clear?
Yes.
Okay, so I just give you your final objective lah for your midterm exam, right? Okay, then you can also have a combinational circuits, right? So like this half adder. Okay, half adder, we have X and Y. Okay, and we have a sum. Okay, right, and we have a carry. Okay, right. So as you can see here, okay, so this is just an XOR gates, and this is an AND gate, right? Okay, for XOR gate, if both input is 1, output will be 0 or 1 class for XOR gates. XOR.
0.
0, right? Okay, so this is a XOR gates. Okay, XOR gate. Okay, this is an AND gate. You can label this one AND gate. Okay, right. Okay. Okay, I close this one. Okay, so for XOR, okay, if you want to do some summation in circuits, okay, you can use the XOR gate. Why? Because for XOR gate, the sum is equivalent to XOR gate. Why? Okay, because if both input is 1, okay, the output will be 0, right? Okay, for XOR, only one input is 1, the output will be 1. Therefore, it is just like sum. 1 plus 1, what is the sum? 0. Am I right, class? Betul tak? 1 plus 1, what is the
Yes.
sum? 1 plus 1.
0.
0. We have carry forward 1.
1.
Okay. Okay, so this one we call as half adder. Okay, so you can derive the half adder diagram here. Okay, or you can derive a full adder. Okay, right? Most probably it's not included in your midterm exam lah. Okay, and then you can have a decoder. So I did just go through with you. Then you may do further readings for your information lah. Okay, then you can have 2 to 4 decoder. Okay, and then we have a multiplexer. Okay, right? And then we can have sequential circuits. Okay, right? Okay, so for this sequential circuit, okay, you can see the binary signal represent 1 and 0. Okay, so the one moving to the top we call as rising edge. Okay, whenever your voltage is going to the bottom, we call as the falling edge. Okay, so whenever you at the top, we call as the high voltage. Okay, whenever you at the 0 volt, we call as the low voltage. Okay, are you clear, class? Are you already clear?
Yes.
Okay, good.
Yes.
Okay, then we have the sequential circuits. Okay, can have several types of flip-flops. Okay, okay. Right, this is just further readings lah. If you are interested, or maybe you can use for your future semesters. Okay, can refer to this one. Okay, and we come to the end. Okay, as a conclusion for chapter 3, actually for week 6 lah. Computers are implementation of Boolean logic. So actually, what I'm teaching you, okay, even though it is takes a little bit of time, is I just want to nurture you to be the future scientist. Okay, so basically the computer circuits is based on Boolean logic or Boolean gates circuits. Okay, okay, Boolean function are completely described by truth table. Logic gates are small circuits that implement Boolean operators. The basic gates are AND or NOT. Okay, the XOR gate is very useful in parity checkers. Okay, the universal gates you can use no or none. Okay, by that indicates the end of our lecture for today lah. So I combine together the lecture and lab parts. Okay, so we remain another lab session or one more session, but it is up to you lah. If you want to have additional class, we can have additional class, or we can trade off with our midterm exam on Friday, right? Is it true Friday? Our exam, midterm exam?
Yes.
Okay.
Yes.
So it is it is we can discuss lah whether you want to have another class, or we can just barter trade with your midterm exam. Therefore, it replace our next class lah. Okay, right. Okay, with that, I think the end of my lecture session. Okay, okay. Anybody have any question? Anybody want to ask anything? Or everybody?
Sir,
Yes. Yes.
about the sequential circuit, the last part, does that include in the midterm also?
InsyaAllah tak masuk. InsyaAllah it's not included. Okay,
Okay.
not
Thank
included
you.
lah. So the one that I focus is until Carnot map, right? So you just focus until Carnot map.
Okay, sir.
Any further question? Any further?
Sir,
Yes.
can I ask the question for exercise?
To exercise.
Exercise 4.4.
4.4. Okay. Regarding the exercise, okay. You may ask first. Let me verify first, because some of the question I need each of you to attempt first. Okay, right. But you may ask. What is your question? Marcus, is it? What's your name?
Weifeng.
Weifeng. Okay, Weifeng. What is the question?
Actually, I want to ask the question 2D.
2D. Okay.
Okay,
Okay. You want to ask about the simplification, right?
Yes. I simplify the question D. I get an answer, and I build an kernel map.
Okay.
the
Not similar.
calculated result and the simplified answer
It's not similar.
is similar, but not all similar.
Different lah, Mr. It is different, right?
But the output of two answer is similar.
Okay. So Wei Feng, you can PM to me later so that I can investigate further. Wei Feng?
Okay, that's all.
Okay. So thanks a lot for asking, because I haven't prepared the details schema answer scheme for that. Okay, but I want to see your answer first. Then I will evaluate based on that because in order to derive the final answer, some of the students have different ways of doing the simplification. Okay, means that they might be using the other rules first. Okay, follow with the other rules. Okay, so it is not really a straight cut. Means that as long as your final answer is correct, okay, you can use any rules first, follow with the next. Okay, Wei Feng, thanks a lot. Okay, any other question before we end our class? No question?
No, sir.
Okay. If you no more question from you, for the time being, I wish you all the best lah. Let's say we are not having any meetings before our midterm exam. Wishing you all the best. Okay, please attempt all the question. Maybe later on I will provide you with the link for the submission. Okay, my final word is I'm really sorry lah for the technical problems that I faced since yesterday. Okay, right? Okay, so with that, I think we can end our class for Muslim with Tasbih Kifarah and Surah Wal As. Okay, thanks to all. Assalamualaikum and good afternoon.
Thank you, sir.
Thank you,
you.
sir.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.